Hi and welcome to Geeks for Geeks. Today we would be discussing a very interesting problem that is again from BST itself, that is brothers for different roots. So my name is Siddharth Hazra and let's move forward. So here the question is very simple. The question is that you are given two BSTs and you're also given a number x. And you need to pick out the elements from both of the BST that sum up to the value x. अर्थात हिंदी में समझा जाए तो आपको दो BST प्रदान किया गया है और आपको एक वैल्यू x भी दिया गया है और आपको हर दो BST से एक एक वैल्यूज लेने हैं. जैसे फर्स्ट BST से x लिया, सेकंड BST से y लिया. x plus y should be the given value. अब let's visualize this with the first example itself. The very first example is 5, then we have 3, then we have 7, then we have 2, then we have 4, then we have 6, and then we have 8 itself. And the very next one is we have something like 10, this one is 6, this one is 15, this one is 3, this one is 8, and this one is 11, this one is 18. Or given value kya hai? What is the given value? The given value is none other than 16. Just remember up this value. So, how many pairs are there which sum up to the value 16? So, you can see that this 8 and this 8 sums up to the value 16. So, I can say that this 8 and this 8 sums up to the value 16. And then we have the very next one, that is this 6 and then 10. So we have something like 6 added to 10, which is also summing up to something as 16. And then the very next one is 5 and 11. Okay, that is 5 plus 11, and that's done. So now, how to solve up this problem? The very simple is that you take up the values from, this is let's say B1 and this is let's say BST2, and what you can do is you can keep up the elements in an array. Okay, first we keep up the elements in an array, okay, in two arrays, that is B1 and let's say A1 and A2. A1 would contain the elements of B1 and A2 would contain the elements of B2. So let's say we have something like A1 would constitute the elements like 5, 3, 7, 2, 4, 6 and 8. And A2 would constitute the elements such as 10, 6, 15, 3, 8, 11 and 18. Now what we really need to do is first take up all the elements and store them in an array, and then what we need to do is we need to sort. After sorting, A1 would become something like 2, 3, and then we have 4, then 5, then 6, and then 7, then 8. And A2, after sorting, it would become 3, 6, 8, 3, 6, 8, and then we have 10, 11, 18. 10, 11, I forgot 15, and then 18. After sorting, this would be the result. So the brute force is easy, I just want to append it. What you can really do is, for each element, you try to find out like if what is asked. Just keep at this point. So the brute force would be that x is made up of element of A1 and A2. A1 plus A2. A1i and A2j. It would be this. X is made up of this. So if x is made up of A1i and A2j, then what you can really do is we can pick up any element of A1 and try to find the corresponding element in the A2. What I meant is, if you just see up this, the very first one is 16. So we can take up 2 and we can try to find 14. Is 14 present? No, it is not. Then we can go up to 3. 16 minus 3 is equals to 13. Is 13 present? No, it is not. Then we can take up 4. Is 16 minus 4, that is 12, present? No, it is not. Then we can take up 5. 16 minus 5 is equals to 11. Is 11 present? Yes, it is. So what you can really do is, as these two arrays are sorted, if this was not sorted, what you can really do is, you can use a linear search to find the corresponding element. But this sorting things gives us a glimpse that we need to search element a lot number of times. So sorting it and then doing binary search would give better result, because finding n elements is n. Using linear search, it is again n. So for finding one element through linear search, it is n operation. So for finding n elements, it would be n square operation using linear search. But if we just sort it, that is n log n. And at each point we would be searching the element. So for one search, binary search is log n. So for n search, it would be again n log n for searching all the n values and for sorting it. So it would be 2n log n. 2n log n, n is better than n square. That is why this solution is better than this. Okay, this is the very first thing that you need to do. But there is one more thing that you can do. We took out the elements and then we sorted. Then we had to do the sorting thing. But can we bypass this thing? So bypassing this thing is simple, that we want the sorted result without sorting. So we need to extract the data in such a way that the data is already sorted. What I meant is that अगर मुझे बिना sorting किए sorted result चाहिए, तो मुझे data extraction BST से ऐसे करना होगा कि वो sorted form में ही आए. Make sense? And this gives us a glimpse that the question is of binary search tree. And you should learn this fact by heart, that in order traversal of BST gives us a sorted result. This is for sure true. Just remember this by heart. Okay? So let's just see this in action. 5, 3, 7, and this is, let's say, 2. So in order means left, root, right. So if I go to 5, it would tell me my left is not done. If I go to 3, 3 would tell me my left is not done. So I go to 2. 2 doesn't have any left, so we would visit 2. So we are visiting 2 at this point. Now as 3's left is done, so we would visit 3 as the root. Then it is 2 is done. Now 5's left is visited, so we would visit 5. And then we have the left one, that is 7. So see, we have a sorted result if we do the in-order traversal in a BST. So what we can really do is, we can skip up this sorting part. Okay, we can skip up this sorting part and we can directly get the sorted result. But still, the time complexity is n log n again. How can we just bypass it more? So getting the sorting thing is now done. But searching the element again and again. So at this point, what the question becomes, that given to sorted arrays, find the number of pairs which sums up to x, which sums up to the value x. This is what is needed, and this piece of cake is a little bit easy to do. How? Let's just write the sorted version of the first BST. That would be 2. Okay, then it would be 3, and then it would be 4, then it would be 5, then it would be 6, and then it would be 7, then it would be 8. This is the very first in order traversal of the first BST. The second in-order traversal of the second BST would be 3, 6, 8. Okay, then we have 10. Then we have 15. No, we have 11. Then we have 15. Then we have 18. This is the in-order traversal of the second BST. Both are sorted. Now, what we can do is, we can just reverse up this array. Reversing up this array would make it seem something like this: 18, 15, 11, 10, 8, 6, 3. This is the reversed form of the second one. Okay. Now, what we would do is, we would take 2 pointers, I and j. Okay. So now, if 18 plus 2 is equals to 20 and 20 is more than 16, good enough. 20 is more than 16. So we need to lower down our value. If we want to lower down our value, so we need to decrease the value. So if we move this pointer, to that side, the value would increase. If we move this pointer to that side, the value would decrease. So if we want to lower down the value, we would just increase this value, that is 2 and 15. Now 2 and 15 is 17, which is again greater than 16. So we need to decrease the value. So now 11 plus 2, it is less, 13 is less than 16. So we need to increase the pointer. 11 plus 13, again less than 16. So we need to increase the pointer. So 11 plus 14, 15, which is less than 16. So we need to again increase the pointer. So 11 plus 5 is equals to 16. This is the very first time we would be incrementing the count to 1. Initially it was 0. Now, both the values are same. They are summing up to 16 and this is done. So now what we need to do is, we need to increase both the pointers. So now 10 plus 6 is equals to 16. So we need to increase the pointer and we need to make this go high. Now 8 plus 7, that is 15, it is less. So we need to increase the value. To increase the value, we need to go on that side. Now 8 plus 8 is equals to 16. So we would again increase the value, increase the pointer of both. As you can see, one of the pointers is outside the boundary. So we have nothing to compare. At the end, we have our result. Okay. This is how you would be getting. So we know a way to have the sorted. How to have sorted? By doing in-order traversal, that is left, root and then right. But if we wanted a sorted reverse ordering, then what we can do is, we can just reverse this, that right would come here and left would come here. So if we visit in this fashion, that is right, root and left, then this would be reverse of this. So for BST1, we would be doing an in-order traversal. For BST2, we would be doing a reverse in-order traversal. These two functions would be already implemented. And then we would be moving forward to the main. Now let's move to the implementation and it would be a feast for you. So this is the in-order traversal. We are visiting the left, root and right. Here we are visiting right, root and left. And here we are calling it for BST1 and BST2 and we are saving it in BST1 and BST2. Now what we need to do is, we need to have 2 pointers, int I is equals to 0, comma j is equals to 0. After this, we would say while I is for BST1, while I is less than BST dot size. Okay, I is less than bst dot size, and they both should be within the boundary so that we can do a comparison. Okay, so we would say j is less than bst dot size, and here it would be bst2 and here it would be bst1. After all of this, we would open a bracket and we would first find the sum. And sum is equals to bst1 dash I added to bst2 dash j. Now, if they both are equal, then we move both the pointers. So we would say if sum is equals to the given value x, we would move the pointer I plus plus and j plus plus. Okay. Else if the sum is less than the given value, okay, what we should do? If the sum is less, then we need to increase the upper one. We were increasing this one, so we would increase I plus plus. Okay, if the sum is less. Else, if the sum is more, then we need to increase the lower. Okay, because lower pointer is reverse. So if we go on this side, that is 7, 6, the value would decrease. And at the end, this one would also be accompanied with answer plus plus. Okay, now let's just compile and run and see how many errors are we making. And seems good. Yep, that's great. So what we can really do is talking about the space complexity. Space complexity, we are taking an auxiliary data structure to save the result. The expected space complexity was big of n, so I'm doing it. But my challenge for you is, can you do this without big of n space complexity? Like you can do the iterative in order traversal and this would be done. Now, this is a simple exercise for you. That's it from my side talking about the time complexity. It is big of n. That's it for today. Thank you and have a nice day.